We continue, got to solve for y. How many x's do we have there? I see one of them. So put that 1 in there and solve for y. If it's negative 1x on the left, it's going to be a positive 1x on the right. Keep the sign in front of the 4. That's a negative 4y. And as we take a look at that, we're going to divide everything by negative. So if we divide by negative, what happens to my less than or equal to symbol? If you divide by negative, the less than is going to become a greater than. So we have y is greater than or equal to 1 over negative 4x, and 12 divided by negative 4 is a negative 3. So I need a y-intercept of negative 3, and if you notice they all have y-intercepts of negative 3. I need the ones that have a negative slope. This is a positive slope. It can't be a. Here's a negative slope, might be that. This is a positive slope. So if you know that your positive slopes go this way, you can eliminate those. These are the two guys that have negative slopes. So basically I just got to check the shading. Greater than, does it shade above or below? It shades above. Answer is B. Down here, determine the solutions by graphing. Oh my goodness, we got to solve for y. So if we divide everything by 5 in this problem, 5 divided by 5 is y. Divide 3 by 5 and you get the fraction 3/5 in front of the x, and if you divide 5 by 5 you get 1. Now if we take this and do the same thing, solve for y, got to do a little bit more moving. If this is minus 4.5x on the left, seriously? I get a phone call during the video? Alright, I just hung up on them. We're going to, I'll probably get in trouble for that. 7.5y is going to be equal to 4.5x plus 7.5. I know there's a lot of decimals, but hey, your calculator will clean things up. I'm going to divide everything by 7.5. If you take a calculator and go ahead and divide 4.5 by 7.5, 4.5 by 7.5, you get 0.6. So my slope is going to be 0.6. So now I have y is equal to 0.6x, and 7.5 divided by itself is 1. So if I come over here and type in both of my equations, I've got my 3/5 x plus 1 and I got my 0.6x plus 1. Well, hopefully you know what's going to happen. If I hit the graph, I get this right here. You may say, well, where's the other line? Go to your table. You have the same line. For every input, you have the same output. So how are we going to answer? We're going to answer C. Since the lines are the same, there are infinitely many solutions. Okay, now look right here. They have, since the lines are the same, there are no solutions. No, that's when the lines are parallel. So make sure you catch the details on this, or it may bite you. Okay. So over here we have a problem where we need to piece together the equations. We need to look for slopes and y-intercepts. So if we look at our two different ranches, we've got Pitchfork Ranch. What's the fixed fee? What's the one-time charge to get in? It's 45, so that's my y-intercept. And that is my rate of change. That's what's purring at me, so that's going to be my slope. So for Pitchfork Ranch, that'd be PR, we're going to have y equals 22x plus 45. X is the number of hours that you ride. If we go to Crier Creek, look at the same thing. We notice a flat fee is $30. That's my y-intercept, and $35 per hour. Okay? And the question is, graph the system and approximate how many hours you need to ride for the cost to be the same. So you have everything you need in order to graph that. Okay? We got a y-intercept of 45. Now you got to be careful. Look at your scale. This is going by ones, but look how far over you have to go 1 on the run. So be careful on that. So if I go up 22, that's going to be up to 67, and then I'm going to go all the way to 1 right here. And so we're going to have our, looking for a ruler, found it. You have this right here. Okay, so that's for Pitchfork Ranch, PR. If we come over here, we got a y-intercept of 30. We're going to go up 35, so that's going to get me to 65, but I'm going to go over 1. And so now I have that. So if we look at the approximate place where they intersect, if we follow that down on my screen, it's going to be a little bit over 1. So at that particular point, what I would do is go ahead and say, let's double check this and say 1 hour, because it's closer to 1 than 1.5. So I'm going to say 1 hour, but we're going to double check this using our calculator. So we have the equations in. Now what I'm going to do, this is a good time for me to talk about setting your window. If you look at the window, my x values go from 0 to 2, and it goes by a scale of 0.5, and over here actually 0.1. Actually it divides that up, it's really messy here. We can just say 0.5 for this, and over here this goes by 1, it goes from 0 to 80. If you want to set your window to match your paper, do it. I mean, look, I have my low value of x is 0, it goes from 0 to 2, and it's going by 0.5, and then on my y, I just typed this stuff in. I looked at my picture and I typed in the same numbers as I saw on my paper. I go from 0 to 80, and I'm going to go by 1. And if I press graph, you're going to have a pretty good picture of it. But that's not why I need it. I need to do my magic keystroke. You remember what it is? It's second, trace, and we want the intersect. Let's go 5 and hit enter. How many times? 1, 2, 3. And if you notice, it's 1.15, blah, blah, blah. 1.1 is closest to 1. And so that's how I know that I'm going to pick this one right here. So if you use the hand version, make sure that you pick up a ruler or a straight edge or something, or you put your equations in your calculator and use the trace, and you don't have to worry about it at all.